Welcome all of you to this video. Today in this video, we will learn how to construct a quadrilateral in certain situations. So far, we have learned the construction of a quadrilateral when the length of 4 sides and a diagonal, length of 3 sides and 2 diagonals, measurement 2 adjacent sides and 3 angles, measured 3 sides and 2 angles between them are given. As you know from the previous video, any 5 measurements are required to construct a quadrilateral. Can we construct a quadrilateral with less than 5 measurements under certain circumstances? Let's discuss this. Suppose you have to draw a rectangle ABCD whose adjacent sides are 4 cm and 3 cm. Can you create a rectangle ABCD using only these 2 measurements? Well done. Construction of ABCD is possible. The measurement of the opposite sides in a rectangle is equal and all angles are 90 degrees. So, we get 8 measurements, 4 sides and 4 angles, from which we can construct the rectangle ABCD. Shikha wants to make a birthday card for her best friend's birthday, in which the diagonal length of a square sticker used is 5 centimeters. Can you help Shikha in making stickers? Shikha wants a square whose diagonal length is 5 centimeters. So, let's write the characteristics of the square diagonal as follows. Both diagonals in the square have equal measurement. The diagonals of a square bisect each other at right angles. Step 1. Suppose the square is ABCD. Diagonal AC equals 5 centimeters. As we know, both diagonals are equal in the square. Diagonal BD equals diagonal AC equals 5 centimeters. And the diagonals of the square bisect each other vertically, which means all these angles would be equal to 90 degrees. Draw diagonal AC equals 5 centimeters. Since both diagonals bisect each other at right angles, make a perpendicular bisector of AC which will intersect it at point O. Assuming O as the center and equal to half of BD, that is 2.5 centimeters radius of measurement, we mark an arc between the perpendicular bisectors on AC as we intersect it at point B and point D. Connect A, B, point B, C, point C, D, point D, A. Thus, the square ABCD is obtained. So, in this way, we can also make quadrilaterals with less than 5 measurements. Today in this video, we learned the construction of some special situations of quadrilaterals. In the next video, we will see some examples based on the same. Welcome all of you to this video. Today we will see examples based on the construction of quadrilaterals. Can you construct a rhombus BEND with diagonal BN equals 5.2 centimeters and DE equals 6.4 centimeters? Create a rough shape. So, let's first construct a rough shape in which BN equals 5.2 centimeters and DE equals 6.4 centimeters. Draw a line segment of any one of the two measurements given. Draw a line segment BN equals 5.2 centimeters. Since we know by the properties of rhombus that both diagonals of a rhombus are always perpendicular bisectors of each other, so now we will consider BN as base and make a perpendicular bisector on it. Which will intersect BN at point O. Since the diagonals bisect each other, we draw an arc on both sides of the perpendicular bisector on BN, taking O as the center of measure half of DE, 3.2 centimeters, with radius of a measurement which intersects it at points E and D. Thus, we get diagonal DE equal to 6.4 centimeter.
Connect the points BE, points EN, points ND and points DB.
BEND is a desired rhombus. You can confirm this with the help of scale and points. You will see that all the sides of the quadrilateral are of equal measure. Today we understood the construction of a quadrilateral with the help of examples. Welcome you all to this video.
Today, we will see the misconceptions associated with the construction of the quadrilateral.
The teacher asks this question in class.
How many minimum values are required for the construction of a unique parallelogram?
The answers of Charu, Meera, and Sonia are as follows. Charu 5, Meera 2, Sonia 3. Can you tell whose answer is correct and why? So let's see why Charu would have chosen option 1. As we have been reading from the beginning, that the composition of any quadrilateral requires the value of 5 measurements, which are as follows. Length of 4 sides and a diagonal, length of 3 sides and 2 diagonals, measurement of 2 adjacent sides and 3 angles, measured 3 sides and 2 angles between them. Hence, Charu selected option 1, which is the wrong answer. Meera thinks that option 2 is the correct answer. Can you tell why she thinks so? Absolutely right. Meera knows that the measurement values of the opposite sides and angles of the parallelogram are equal and she thinks that if the measurement values of the two sides are known, then it is possible to construct a parallelogram. Suppose the measurement values of adjacent sides AB and BD of a parallelogram are 7 centimeters and 5 centimeters, from which we can conclude the following.
Yes, in this case, a parallelogram will be formed. But will it be unique? Let's discuss this.
Suppose we construct a parallelogram ABCD in this way. The measurement values of the adjacent sides of ABCD are 7 centimeters and 5 centimeters. From these measurements, we can also construct a rectangle. So we can say that by measuring the adjacent sides, a parallelogram will be formed, but it will not be unique, because in this way, rectangle can also be created. Therefore, a unique parallel quadrilateral cannot be constructed by the value of adjacent sides only. Now, the question is, how many more measurements do we need in addition to the adjacent sides? We have the measurement value of all the sides of a parallelogram. So how many angles will make a unique parallelogram?
Let us discuss this. Yes, if we know the measurement value of a single angle, then the measurement value of all the angles can be found, since the angles of the parallelogram have equal measurement values and the adjacent angles are complementary. For example, if the measurement of adjacent arms in equation has a value of 7 centimeters and 5 centimeters, and measurement of angle B is equal to 70 degrees, we get angle A and angle D equal to 110 degrees, and angle C will be equal to 70 degrees. In this way, we found the measurements of all the angles of the parallelogram, and taking these values, a parallelogram can be created. In this way, we need only 3 measurements, 2 adjacent sides and 1 angle to create a parallelogram. So, Sonia's answer is absolutely correct. Today, we saw the misconceptions associated with the design of the quadrilateral.